Hello folks, welcome to our latest math adventure. This is chapter 10, which is all about solving linear equations. In many ways, it's the companion chapter to our previous one, which was about identifying linear equations, putting them on graphs and tables of values. But now we get to the fun part, which is solving them. It should be short, sweet, and painless. For me. Okay, so before we get to the good part, we need to go over a couple definitions. We want to make sure that you're not being confused if you don't know a certain term. So one of the things we're looking at in our linear equations are variables. Variables, often you'll see it as an x, but it could come up as any other letters. A variable is a value that is unknown. And of course, depending on what question you're trying to solve, that x, or whatever letter it could be, may have different meanings. As we saw on the graphs and tables of value we had, depending on what the value was on the x or the y-axis, it changed what the other one was corresponding to it. That's why it's variable. It won't always be the same value. That being said, there are some constants in life, and they are known as constants. If we just see a straight number, such as the number 5, that number is always going to be 5. It was 5 long before you were born, and the number 5 will still be 5 long after you passed away and are moldering in your grave. But now there are some numbers that are a little bit different still. They fall in that mushy middle. They may look like constants, but the truth is they're really not. They're actually the diabolical henchmen of the variables. They are the numerical coefficients, yes, and we've seen this already. If we see the value 5x, if we see 5x, well, that depends on what x is, correct? But we know whatever x is, whatever our variable is multiplied by 5. So whatever happens to be before the variable and is multiplying it is our numerical coefficient. Sometimes our numerical coefficient could essentially be division. You could have 1/3 of x, which is the exact same thing as x divided by 3. Which brings up an interesting point, because even if a number doesn't appear, even if a variable doesn't appear to have a coefficient, the truth is, it does. Just give me a second here. If you don't see a coefficient, that means that the coefficient is 1. The thing is, we just usually don't bother to write 1x. We just say x equals 5. We don't usually write 1x equals 5, but if you wanted to, there's nothing incorrect about doing that. So just keep that in mind, because that helps make sense of division questions or situations where just knowing that 1x over 3 is the same as x over 3. Okay, so a few key terms. We're now going to be looking at solving one-step equations. We'll then go on to two-step equations, and then the distributive property. So if this is not your first time watching this lesson, then feel free to skip ahead to whichever section you need to. I've included little segments in the description of this video where you can do that. Likewise, if you wanted to just watch part of it and then pause and continue, feel free to do that. Okay, so we are going to look at some one-step questions. I'm going to grab a fresh piece of paper here. And so what we do is perform the opposite operation. It's also sometimes known as the inverse operation to get a variable by itself. Ultimately, our goal with all of these questions is to solve an unknown variable. So before we get into word problems, let's just look at some basics here. So let's say 5x equals 15. Here's our equation. We're solving for x. Now, you're probably thinking right now, okay, 5 times 3 is 15, right? You can do that much in your head. And that's great for simple questions, but we want to look at the steps. How would we do this? Because as we'll see, it gets more complex. You want to know the basic principles of opposite operations. So, we're getting x by itself. Right now, x is multiplied by 5. What is the opposite of multiplying something by 5? It is dividing it by 5. That's correct. So we're going to divide each side of the equation by 5. So 5x divided by 5 equals 15 over 5. You can perform a nice little eye test here for you. So 5 divided by 5 is 1. So 1x, I'm just going to write x. I'm not going to bother with writing out the coefficient of 1. 15 divided by 5 is 3. Therefore, x equals 3. Simple enough, right? Now, the thing is, though, as simple as it might seem, we can make mistakes. And in fact, I'll be honest, this was not my first take. I made a big mistake, but I caught it because there's a way that you can solve and check your problem. The way you do that is you go back to your original equation and you plug in the value that you found. And if both sides of the equation are equal, then you know that you were correct. If they weren't, then as in my case, you know that you made a mistake somewhere along the way. Okay, so our original equation was 5x equals 15. So we're going to plug in a 3 for the x. So it says 5 times 3 equals 15. And that's simple enough. You know 5 times 3 is 15. 15 equals 15. Therefore, our answer was correct. Our value for x is correct. X does equal 3. Okay. We're going to go ahead and try that with a division question. This time, we're going to use a word problem. We're going to say that there was an old man, a wise old man, and he invested his money in a jellyfish farm. Made his fortune. But he wasn't all about work and jellyfish. He was also a man of pleasure. And his greatest pastime was jumping motorcycles over barrels of gunpowder. And one day for his birthday, he said, I'm going to do it. Mabel, I'm going to jump my motorcycle over 17 barrels of gunpowder. And by golly, he almost did it, but his back wheel hit the edge of the one barrel, caused a massive explosion. He was blown to smithereens. Fortunately, though, he wrote a will, and he had money that he gave to his 5 children. He had 5 children, and each one of them got $800. The question is, though, what was his original fortune if each child got $800? So let's write the equation. Often the hardest part of a question is just figuring out what is your equation. Solving it then is just the lovely little puzzle at the end. Okay, so let's use a different letter. Let's use the letter F for fortune. I think F is everyone's favorite letter. You always want to write at the side or at the top of your equation, what does the variable represent? Because we're playing around with 3 numbers here, aren't we? We're playing around with his original fortune, his number of children, and the amount that they each received. So you could easily manipulate the question and ask, how many kids did he have if here's what he started with and here's what they each got. So make very certain you write that at the side. Let F equal his total fortune in dollars. You can even write the unit there. So F, he divided that total fortune by 5 people, and each one as a result got $800. So F divided by 5 equals $800. Beautiful, isn't it? So now F divided by 5 gives us 800. What's the opposite of dividing it by 5? Once again, performing the opposite operation. The opposite of dividing by 5 is multiplying by 5. That's right. You make me so proud. Okay, so let's do that, shall we? So F times 5 divided by 5 on one side of the equation, 800 times 5 on the other. Okay, so once again, these two will cancel each other out. Multiplying and dividing by 5, they come out to 1. I'm not even going to bother writing the 1 as the coefficient. And 800 times 5 is 4,000. So F equals 4,000. Therefore, his original fortune was $4,000. So in this case, yeah, that's straightforward enough. I'm not going to bother checking that over by plugging it in. I will, though, for our next question. A 2-step question, because that's the one where I made a bit of a mistake on one of my earlier takes. Okay, we're going to talk about hockey, because hockey may be gone, but it's not forgotten. And what's especially not forgotten is the 2006-2007 season, because that was when I was in grade 12, but the reason I've talked about that is because it's also in your textbook. I'm taking an example straight from your textbook, which you can find the pages digitally of these units in content if you left your book at school. Okay, so we're talking about two players on the Calgary Flames, Christian Huselius and Jerome Iginla. Iginla was the big star. He was the big goal-scoring stud there, but Huselius was pretty good in his own right. And so it said Huselius, in this season, he had 41 more shots on goal than half of Jerome Iginla's total. And if Huselius had 173 shots, how many did Iginla have? So we could just go to NHL.com and look those numbers up, but that won't teach us anything, right? So what we're trying to solve is Iginla's number of shots. So let's do I. Let's use the letter I for Iggy's shots. And I'm going to use a lowercase cursive. See, we often use the cursive letters here just so that they don't get confused, especially with the multiplication sign if you're using times. That's why you so often see X written in cursive writing. So Huselius had 173 shots, so let's say 173 equals Iginla's shots divided by 2 plus 41. So he had more than half of Iginla's shots. So how I've written this, in this case, our variable is on the right side, and honestly, it doesn't matter, essentially, as long as you've isolated the variable. It doesn't matter if it's left or right. In this particular case, the reason I put 173 is because we know that's the total that all of this other stuff equals out to. So now all we have to do is isolate the I. Now the challenge here, though, is that we have two steps. So we are actually going to do the reverse order of operations. That's what we do. Before we can go multiplying this I by 2, we have to get rid of the plus 41. But opposite operations still apply. So if we're adding 41, how do we get rid of that? We subtract 41. That's right. We subtract 41 from both sides. And I'm about to confess to you and tell you the dark secret of where I made the mistake. It was on this question. Okay. So we have 173 minus 41 equals I over 2. We haven't touched that yet. Plus 41 minus 41. So we'll be able to just get rid of this whole caboodle right here with the addition and subtraction because they cancel each other out. And my mistake was that you're supposed to subtract here, right? And I added it. So that screwed me up, but I checked the answer and avoided embarrassing myself online. Okay, 173 minus 41 is 132, that's right. And if it's not, we'll catch that, equals I over 2, because the addition and subtraction on the right side came out to 0. Okay, so now we're in familiar ground again. I over 2, we need to multiply that by 2, right? Because it's right now divided by 2. Opposite operation. So we're going to multiply each side by 2. So 132 times 2 equals I times 2 divided by 2. And that comes out to be 264 on the left equals I. Okay, now here's the moment of truth. We are going to go back to the original equation and we're going to plug 264 into I. And if it comes out well, if both sides of the equation equal each other, then we know we have solved this bad boy. Okay, so the original equation was 173 equals I over 2, so we're going to go 264 over 2 plus 41. Here we go. So all we have to do now, because there are no variables here, all you have to do is crunch all the numbers, simplify. And it should hopefully say 173 equals 173. So in this case, you are going to use the order of operations. You are going to use BADMAS. 173 equals, so 264 divided by 2 is 132 plus 41. Aha, I've got cat-like reflexes. They could have put me in net that season, and they wouldn't have been eliminated in the first round of the playoffs. Okay. So 173 equals, and 132 plus 41 is 173. So in this case, yes, we are correct. Two-step questions. Now, very similarly, if it had said that Huselius's total was, let's say Huselius turn into some kind of hockey monster, a hockey god, and he had 5 times Iginla's shot total, 41. Let's say he had 41 more shots than 5 times Iggy's shot total. We need to also write a sentence there answering with this question. But if in that case, it would be 5i plus 41. And then just like we did before with one-step operations, we would be, if we had 5i equals 132, we would then divide by 5. Same opposite operation to get I by itself. But in this case, once again, always we want to have our word problem solution written in a full sentence. So we're going to say Iggy took 264 shots on net. Yes, so always make sure you know what is it actually you're solving. Because math should have a purpose, correct? And if you just have a number, what does that mean? Okay. So this takes us to our last part of the lesson, the distributive property. So this is where we actually get some brackets. We get some numbers and brackets that are being multiplied and variables. So this is where it gets really fun and really satisfying. I'm going to keep the door closed so no one can hear what's going on. Okay. So one of the word problems that you see, a very common one, is with area. And there's actually one you see there. I'll just come up with my own numbers in the text from the textbook. But they say that there is a yard. So we've got a yard, and we've got a lovely little house. Yes, isn't it beautiful? Okay. So take a look at this beautiful yard and the beautiful house. Yes, it's a beautiful combination of 3D and 2D. And we're trying to figure out part of the side of the yard. You see that the house is not as long as the yard, this front side of the house. And this unknown value is this little stretch right here. So in this particular case, you know what, let's go ahead and actually use the same values from the textbook. That'll be nice and handy. Okay, here we go. Flower garden. So the total area of these two numbers multiplied by each other of the flower garden, it's in the shape of a rectangle. The length of the garden, it says, is 2 meters longer than the length of the shed. And so the width of the garden is 4 meters. So here's what we know. I'll put this on the diagram for you. And we're trying to find out what is the length of this shed. So they're going to use the letter S and 2 meters. And the total area is 20 meters squared. Okay. So for goodness sakes, you're wondering, what exactly is the length of the shed? And what, even more importantly, are we going to set up as our equation to figure that out? So in this particular case, there are a couple of numbers multiplying together to become area, right? So for area, we're going length times width. So we can think of it this way. We can think of, I'm going to write length times width equals area. And let's plug in what we do know. We know the area is 20 meters squared. So I'm just going to write 20. We know that the length, or we can say the length, is the shed plus 2 meters, and that the width is 4 meters. Okay, so the width is 4, so times 4. The shed plus the extra 2 meters equals this side. So these two sides multiplied equal the area. And how you'll see this written is you'll see that the 4 is put before these brackets. So it'll say S, and I'm going to do a cursive S, S plus 2 equals 20. Okay. So the question is, something plus 2 times 4 equals 20. And we need to find out the length of the shed. So how do we get this all by itself? Once again, we are going to go with opposite operations. It's just that it takes an extra step there. There are 2 different ways we can solve this. One of them is, first off, let's look at opposite operations. This one is lovely because it works out that they multiply together very nicely. Turns out that 20 is a multiple of 4. So right now, this whole thing, s plus 2, is multiplied by 4. So we're going to divide it by 4, right? That's the opposite operation. Divide each side by 4. Now the reason that we're not going to subtract the 2 instead is that it's in the brackets. It's in the brackets with the s. So that whole entire thing is multiplied by 4. Now if it just said 4s plus 2 with no brackets, then we would subtract the 2. But no, with the brackets that's not the case. So in that case we have s plus 2 equals 5. And you'll notice I got rid of the brackets because there's nothing else that's happening to them outside of s plus 2. So we're okay there. So I'm going to now we can just do opposite operations. S plus 2, to get rid of the plus 2, we can subtract 2 from each side. And you've probably figured out already just in your head that it's 3. Because what plus 2 equals 5 after all? Okay, s plus 2 minus 2 equals 5 minus 2. Comes out to be s equals 3. So I want to show you now another way of looking at this, the distributive property. And you might be wondering, Mr. Genet, this was simple enough. Why would we bother using another way? Well, in this case, the numbers turn out to be very nice and even, and they multiplied and divided into each other. But that won't always be the case. And so in many cases, the distributive property will be a lot easier way for you to get the s by itself. Okay, so let's go back to the beginning where we had 4 multiplied by the s plus 2 in brackets equals 20. Now with the distributive property, what you're going to do is you're going to take the number outside of the brackets, in this case the 4, and you're going to multiply it by each of the terms inside here. So we have the s and the 2. So what will that look like? Well, let me show you. So 4 times s, we look at what is 4 times s. 4 times s is 4s. What is 4 times 2? It is 8. So we see that multiplied out. Now this is pretty straightforward because all the numbers are positives. But just like when we looked in our chapter 8 about integer operations, if you had, let's say, where it would happen to be s minus 2, then the rules of negatives and positives still apply. So if it were s minus 2, it would be 4s minus 8. Likewise, if for whatever reason we had negative 4 on the outside, then we would have negative 4s minus 8. So those rules still do apply when we're using the distributive property, it's called. By the way, I missed something here. Let s equal the length of the shed in meters. You always want to make sure you write that. Okay, so in this case now we have 4s plus 8. It's just another two-step operation. So we are going to, first off, remember we want to get rid of the addition or subtraction first. So we're adding 8, we're going to go minus 8. 4s plus 8 minus 8 equals 20 minus 8. Comes out to be 4s on one side. 4s equals 12. So now it's 4 times s. We need to divide by 4 to get the s by itself. S equals 3 because 12 divided by 4 equals 3. And that is also what we got using our opposite operations from the beginning. But maybe we were wrong on both counts. Maybe we made the same mistake somewhere along the way. So let's plug that in, shall we, and see if, by substitution, if our answer was correct. Okay, so we had 4 times s plus 2 in brackets. So I'm going to go 4, and I'm going to use a square bracket. When you have a bracket inside a bracket, you can use a square bracket. 4 times 3 plus 2 equals 20. So this is what it will look like. And I just made a bit of a mistake there, above there. So just because we always like to show when we're substituting that we have brackets, so I use the square ones. So we'll do the stuff. Now, remember, when you know all of your numbers, when they're all constants, then that's where you use BADMAS. So we have 3 plus 2 inside the brackets equals 5. So that gives us 4. 4 times 5 equals 20. We know 4 times 5 equals 20. 20 equals 20, therefore our answer was right. And we can say that the shed is 3 meters long. Beautiful. A hard day's work. Shed is 3 meters long. Okay. And yes, you do want to work down. You do want to show all of those steps. Because maybe you catch your error, but if you haven't shown your steps, you don't know what that error could be. Okay. So this concludes our look at solving linear equations. We've looked at one-step operations, two-step operations, and the distributive property. I wish you all the best, and we'll be in touch about any challenges, any concerns that come up, and have yourselves a lovely rest of your day. Take care.